Is an alternate technology to your classical asynchronous replication. It can actually be used with it, so you can have a number of machines connected using Galera, and it can actually do the normal bin log replication to another machine, which at the same time. So they're independent, but they can actually be worked together in the same kind of way. All the masters are actually all active at the same time, which is what you didn't actually have with your classical replication. And the reason you can do this is it's because it's synchronous. So when you actually do the transaction in a Galera group of machines, that the transaction is copied to all the other nodes before it actually returns a success to the application. So if you can read off the machine you're connected to it, you can read off any other machine and actually get the same data. And so there's not the usual lag that you had previously with your classical replication. It's automatic provisioning. So what you can actually do is you can install Mariadb 5.5 with the Galera extensions and say, join this group of machines. It will nominate a machine in that group to donate all the data across, and it moves all the data across using MySQL dump, XtraDB, or rsync. For those that noticed, some of these will actually require that node to go offline. So XtraDB can actually keep InnoDB tables online while it copies them. The rest actually have to shut down the machine to actually copy the full data set across. However, at the end of the day, you will actually have a full data set on both machines, and that will, through a state process, actually eventually catch up with the data. These are the ones they've just implemented. You can actually write your own script to actually do your full copy of your data set across. So if MySQL dumps too slow, you don't trust extra backup, you can write something in the middle that will actually work for you. Like Stephen said, in MongoDB, you have to have at least 3 nodes, and that's basically because in a split brain situation, how will 2 nodes actually know which is the boss and which isn't, and which is up to date and which isn't? So you have to have 3 nodes. Like MongoDB, you can have an arbitrator, and it's the same kind of situation. It's not essential that it's there. It's basically a point in the network that has an independent view that sort of can help with decisions without actually storing the data. Like MongoDB, that an extra node is still extra data and useful, but if you don't have the storage, there's an arbitrator that actually performs the same function. It's optimistic locking. As you can imagine with a synchronous thing, if you try to actually obtain all the locks on all the nodes before you actually try to write something on every single transaction, your throughput will go through the floor. As per the Wikipedia page on optimistic locking, that it's only useful if you've got a low data contention, if you're not actually likely to write over the same data at the same time. And as a consequence, if you do actually happen to overwrite the same data at the same time, you will get a deadlock and your application will be expected to deal with it. But that's the same with any other transactional-based systems that, you should expect failure. Not like many of them actually do, but that. Because it's synchronous, it could also actually be used across a wide area network. However, what's your latency? It adds to the commit time, as expected. So what happens in the architecture is you've got a number of connections coming in. It goes through the aspects of the API, and eventually, I guess, you use your Galera kind of components to actually communicate over it. And your storage engine at the other end is independent. However, like I said, with MyISOM, it's not transactional. If something fails halfway through, you will get half a commit, and that's not pretty. So it uses, based on a couple of papers that were actually written about 2000, they actually wrote a reference implementation in Postgres, and not ever got merged, but hey, it sort of shows how synchronous replication can actually be of benefit. When you consider the bandwidth and latency to a hard drive and the bandwidth and latency to a neighbouring device, you've got the benefit that if you're actually replicating to a neighbour across a reliable network that's pretty close and that's got a reliable power supply, you can actually get a faster throughput by synchronizing over network to synchronizing to disk. And that's why when you read the Mariadb Galera documentation on how to actually deploy it, it actually suggests turning off the InnoDB fsync on commit kind of things, because once you've actually replicated it across to its neighbouring node, you're assumed to have the same thing. Keep in mind that may not be the case in your situation, so make sure you know how your hardware and your fault tolerance is. So how it works, it sort of bundles up a set of update and select kind of things in a transaction. It pushes them across, and it sort of verifies that it sort of can be written to, and then it commits it. So that way you've actually got the synchronous commit actually across all the nodes. It's a galera in itself is a mechanism to ensure your data is consistent. It doesn't actually perform the load balancing. That requires either something like CoreSync or, not CoreSync, the pacemaker to actually assign either a virtual IP across to make those connected, or it can actually do, there's an LD preload on a connect function that can actually do a, on the application to actually make it randomly select which one to connect to. What Galera and Mariadb have done in their implementation is that obviously one of the nodes can at any stage become faulty and go into a fault state, but there's a script that can actually instigate off to let some either monitoring device know that something's gone wrong with a particular node, or it could actually trigger off another number of like CoreSync commands to actually remove a resource, remove or move a virtual IP across. So it's actually got a reasonable level of flexibility in the synchronization to deal with failure. Here's a graph that they've actually done for Mariadb 5.1. The line at the bottom is just the plain Mariadb, and what they've done is they've put the Galera Mariadbs up ahead. They've done what I said before. They've actually removed the InnoDB flush on sync on the bottom one, which is, I guess, why you get a fairly instant jump between plain Mariadb and Galera Mariadb on one node. As you can see from the graph, you still actually get an increase in throughput as you actually add more machines in terms of transactions per second. The bottom graph on that is the number of threads, which is how much concurrency you're actually doing. So you can actually pump a large number of concurrent updates and still get performance throughput on those. Galera's got a number of mechanisms so that to avoid contention and to actually apply change sets at change write sets at the same time. So if you're updating one table and another table at the same time, it actually can do those concurrently on those. And okay, so as I said before, it replicates before commit. It can actually order the events, so you'll never actually generate two transactions in an application code and sort of reverse them, so that way you've actually got your consistency, and it'll detect, I guess, further on events and fail them over. But the important thing is, and I guess that's the same as if you're dealing with any application code that deals with a database, you've got to actually expect a commit to fail. And how you deal that in the application is up to you. Throwing an error on a web page that sort of says couldn't do it, sometimes isn't good enough, because what's the user going to do? They're going to retry anyway, so you may as well retry in your application. As I said before, if you value your data, use InnoDB on it. The MySQL's system is always MyISAM, and that's still the case. That's actually not a problem, provided you use your system commands of grant, revoke, create user, drop user to actually manipulate those tables rather than any direct manipulation of the MySQL tables. Because of some deadlocks, you can only do general and slow query logs to a file, and that's probably just an internal issue as to why you can't do it to a CSV file. I'm not sure exactly why, but there is. All tables must have a primary key. InnoDB has one whether you specify it or not. However, make it explicit, and that way you won't have any problems. It should be the case anyway, because if you don't have a primary key, what chance have you got of actually making sure data is consistent if you do have a failure? So it's important to actually just have primary keys, and you avoid that problem. And like I said before, you've got to actually handle errors in commits. That was all. Do I have any questions?
Hi, so are there any strategies beyond failing commits for two different comments, fighting it out as in last minute wins, or anything more sophisticated than that?
No. It's basically
so no plans at all?
Yeah, the first commit that gets through wins.
Okay, and that's always the case?
As far as I know, yeah.
Everybody's asleep.
Is that the case? Surely there's more.
There was coffee before, come on.
There was. And it was really strong coffee too. Down the front.
You don't see lions, see penguins? Or is that...
Any questions related to Mariadb? I'm sure there's a botanist sort of conference later, but it's not it. Sorry, don't know. I guess what I was saying before about there being the ability to actually repopulate an entire data set automatically. There's also a write set queuing. So if a machine actually goes offline for a little bit, it'll actually just catch up on the incremental changes. If you totally destroy a machine and don't notice for 2 weeks later, shame on you for not having monitoring, but when it comes back online, it will actually try to automatically resync the entire database, which might give you a surprise. As I said before, a minimum of 3 nodes, so when a machine actually comes back online, it will actually take a donor machine offline, if that's what your scripts say, and normally that will be required to generate a full synchronization back. If I stop now, Tim will have to run faster.
I was just curious to know what the migration process for MySQL from Mariadb is. It straightforward?
Yeah, pretty much. Keep in mind the code base of the version, so it's version 5.5 MariaDB onwards. So if you've got just normal migrations, if you're on 5.3 of MariaDB and moving up, you've still got a few tingling issues with some of the options are deprecated, but really it's pretty straightforward.
Your file reading is good.
Yep. As far as what they regard as release quality, it's what Monty at Mariadb sort of regards as release quality. So they haven't actually put a final, absolutely production stable as anything stamp on it, but they've actually, it's been around for 3 years. I'm sure someone will correct me on that, but it's actually been through a fair refinement step for that. And before that, Galera has actually been deployed in other replication technologies at the same time. Come on, tricky questions. There's got to be one. Nothing? What's that? What?
Why do you have a logo similar to Oxco?
Don't know.
Don't.
I know, and they're the ones I can't answer.
I assume somewhere online there's plenty of documentation about
The question was, where is the documentation for this roughly? The best, did you want to clarify that any further?
Well, specifically I'm interested in exactly how you detect and resolve deadlocks, how the serialization works of your commits if you can write to any master.
Yep.
That is maybe something you can explain right now, or maybe I need to RTFM.
So you're wondering if you write to a master, how is it ensured that it's in sync?
How do you ensure that I'm not doing the exact same write operation to two masters at the same time?
You don't. You handle when it fails in your application code.
Right.
So you don't actually preemptively lock anything. In fact, you can't actually lock any tables, and you probably shouldn't be anyway. There's things called transactions. You should use them. Okay, so the network communication between nodes is just over TCP, though the latest versions actually can implement a UDP multicast if you've got that network support. Anyway, I've got nothing more to say. I'm not going to ask more questions of myself. If you think of something later, bug me or email the email address there.
Thank you, Daniel.